All right, so this is section 4.3 of Math 146. In this lesson, we're going to talk about the inverse, sine, cosine, and tangent functions. We've already talked about inverse functions in the previous section. We're going to focus specifically on the trig functions, sine, cosine, and tangent, in this in particular section. So let's first of all talk about the fact that and I have to assume that we're pretty okay with the general graphs here by now. But the sine function looks something like this. And then, of course, it continues on in both directions. And if you remember, in order for something to have an inverse that's also a function, it's got to pass not only the vertical line test, but the horizontal line test. The sine function obviously passes the vertical line test everywhere. But as you can clearly see, the horizontal line test fails at almost every single possible place because it oscillates back and forth between 1 and -1 constantly. So I could put a horizontal line anywhere, and it's going to obviously fail. It's going to cross through multiple points on the curve. So in order for you to actually have a function for sine and cosine specifically, because it's basically the same graph, you have to restrict the domain. And we also have to restrict the domain for tangent, but it's for a slightly different reason. So while there are technically a bunch of different ways you could do this, the ultimate idea is what you want to have is you want to cover all of the positive and all of the negative values that sine can go through consecutively without breaking it up. It's become pretty common place that mathematicians have agreed that we're going to include the first quadrant with every inverse trig function. So the first quadrant would, of course, be 0 to pi halves if you're thinking about this on the terms of a unit circle, or here, 0 to pi halves would be this space right there. That's all the positive values of sine. As you can see, they range from 0 up to +1, because that would be +1 right there. So that's going to cover all of our positive values. Now, if we were to keep going into the second quadrant, well, that just repeats all the same positive values. So if I were to continue this up to pi, that's just going to repeat all those same values, and I don't need that. So we're already covering all the positive values here. I don't need to do it again. But what we do need is all the negative values. And we don't want to break up the quadrants, so I don't want to go into the third quadrant and say from pi to pi half, 3 pi halves, to do this. So instead of going forward, we're actually going to go backwards on the graph. So we're actually going to go this direction down to here. And now what you should be able to see there is in the orange, because this will now be -pi/2. What you should see there is in the orange, that covers all of the positive and negative values that sine can produce, but it's also going to pass both the vertical and the horizontal line test, restricting the domain to values that only lie in between -pi halves and pi halves. So if we restrict the domain, the inverse sine, for the inverse sine to become a function, you have to restrict sine itself to only exist between -pi halves and pi halves. So inverse sine of x or theta or whatever it is going to have a restricted domain between -pi halves and pi halves. So that's where inverse sine is going to be restricted. So now let's look at what cosine would do. Again, cosine is basically the same graph. It's just been shifted by pi halves units. Something like that. That was kind of horrible, but you get the idea. And we want to have all the values in the first quadrant. So from 0 to pi halves gives me all the positive values. But now if we were to continue on into the second quadrant or go up to pi, we're going to cover all the negative values of cosine as well. which is great because now you basically have first and second quadrant values. So cosine is going to be restricted between 0 and pi. No need to go into the negative values because as you can see, that would just cover the same positive values that we've already covered for cosine. So if we have negative angles, in this case, it would give you the output would still be all the same positive values. So let's go first and second quadrant. That'll cover all the positive and negative outputs that we need. And then tangent is also restricted, but tangent is restricted because you're going to cover all the positive and negative values here, but there are, if you remember, asymptotes between negative pi halves and pi halves, but that is typically one full cycle right there of tangent. The reason that, I mean, technically, and I'm going to sketch this in there, technically it would keep doing this over and over again. So I could use the first quadrant here, and I could use the second quadrant, but the reason that we don't is because it's split by that asymptote, and we want these to be consecutive quadrants. So instead of having the first and second quadrant, we're going to get rid of that completely. We're going to go back to the idea, just like we did with sine, that it's going to be in the first and the negative first quadrant. And that'll take care of all of our positive and negative values. So the only difference actually between sine and tangent when it comes to this for their inverses is that the inverse tangent is also negative pi halves to pi halves, but because of the asymptotes, you cannot include those. So those get the parentheses instead of the solid brackets. So when we are asked to find the inverse tangent or inverse cosine or inverse sine of something, what you're actually asking is you're trying to find out what the angle is that would produce the value. Okay, and if that doesn't make sense when we do an example, I hope that it will. So for example, if I were to say, let's find the inverse sine of 1. Well, what that question is really asking is saying if I took the sine of an angle, whatever the angle is, it should produce the value 1. So this is where you really do have to kind of be good and know your values of your trig functions. Well, that's going to happen up here, if you think about it, right here at pi halves. That's where sine is going to produce 1. Obviously, sine is going to produce 1 here, and there's an infinite number of places, but it has to be within our restricted domain because otherwise we could not call it an inverse function. So in this case, sine inverse of 1 is going to be pi halves. You're asking yourself, what's the angle on our restricted domain that is going to give us the value of 1 when I do sine? That's what it is that you're looking for. Technically, the way you would actually do something like this, or the way you would actually write it out to solve it, is you would say, I'm trying to extend my screen. There we go. You would say, okay, I've got sine inverse, and that's going to equal some kind of an angle. Well, in order to undo sine inverse, what you really need to do is composite that inside of sine. So you would really say, I'm going to take the sine of both sides. I'm going to take the sine of sine inverse of 1, and that's going to equal the sine of theta. I am taking the sine of both sides. Well, the sine of sine inverse, because they are inverse functions of each other, will just give you the argument, which is 1. And then this side is sine of theta. So again, you're trying to find out what is that angle that's going to produce 1. And in this case, theta would be pi halves. Two different ways of kind of approaching the same problem. Just remember that it is restricted. That's the biggest thing. Sine, cosine, and tangent have restrictions on their answers between, again, negative pi halves and pi halves for sine and tangent, 0 to pi for cosine. So let's say we wanted to find the inverse sine of negative 1/2. So my thought process personally might be slightly different than everybody else's, but the first thing I'm saying is, okay, it's producing a negative value, which means it's going to have to be in the negative first quadrant, or the in between negative pi halves and 0, because can't be first quadrant, everything's positive there. So then I'm going to ask myself, where is sine going to normally give me 1/2? What's that reference angle? And again, this is the first one that I chose to memorize. That's at pi sixth. But it can't be at pi sixth because that's first quadrant. So we know it's got to be negative pi sixth, since it has to be in that negative first quadrant to produce the negative 1/2. Again, there's all kinds of different ways that you can go about thinking about this, but that's how we're going to do it. If you have to do this in a calculator, hopefully you're versed enough in the calculators to know where your sine, cosine, and tangent buttons are. Well, the inverse sine buttons are the ones that are right above that. So a lot of times you have to push second and then sine, or second and cosine, to get the inverse sine, inverse cosine, and so on. I'm not going to run through that. However, if somebody needs to see a tutorial or something on that, I can do that pretty quickly. Just know that they are always going to give you the whatever the acute angle would be, because technically you could probably have an obtuse angle here. The calculator is always going to spit out the acute angle, the angle between 0 and 90 degrees. So I think that takes care of the general idea of what we're looking at. Now let's make it a little bit more complex in the fact that now we want to find, let's say we want to find the sine inverse, or the inverse sine of the sine of pi eighths. Well, once again, inverse sine and sine, basically, since they are inverse functions of each other, will undo each other, and that will give you the argument. As long as your argument is within 0 to pi halves, or 0 to 90 degrees, if you happen to be in degrees, your answer is going to be the argument. Anytime you have the inverse and the regular of a trig function composited, the argument of that, which is this thing right here, is going to be your answer, because that is already in between 0 and pi halves. It's when you have something which is outside of that that's going to be an issue. So what if we had the inverse sine of the sine of 5 pi eighths? Well, okay, so that one's a little bit different, because 5 pi over 8 would actually lie in the third quadrant. And if you think about that, second quadrant, wow. Because 4 pi over 8 would be pi halves. So 5 pi over 8 is going to lie in the second quadrant. Well, sine is still positive there. So what we're trying to figure out is, what is the positive result, but it still has to be restricted from 0 to pi halves. Because remember, sine, again, I'm going to keep saying this over and over again, sine is inverse sine is restricted from negative pi halves to pi halves. Well, sine of 5 pi eighths is second quadrant. Sine is still positive, but that is outside of our domain. So the answer is not 5 pi over 8, because that's outside of negative pi halves to pi halves. So we need to figure out what the first quadrant equivalency of 5 pi eighths is. So basically what you have to figure out is, what's the reference angle? And 5 pi over 8 is exactly 3 pi over 8 away from its closest x-axis. Let me sketch that real quick for you. So 4 pi over 8 is pi halves. So 5 pi over 8 is somewhere around here. Okay, that would be 5 pi over 8. But the reference angle is the closest to the x-axis. Well, if we're counting in eighths, pi, which is over here, would be 8 pi over 8. So in order for me to get from 5 pi over 8 to 8 pi over 8, that's a difference of 3 pi over 8. And 3 pi over 8 would then be the first quadrant equivalency. So the answer to this is 3 pi over 8. You have to find the answer within the domain of negative pi halves to pi halves. All right, so let's change things around just a little bit. Let's do the trig function on the outside and the inverse trig function on the inside of the parentheses. So we'll composite the inverse on the inside. So let's say that we want to find the sine of the inverse sine of 0.8. So again, what the inside is saying is that there's some kind of an angle that's going to produce 0.8. That's what this piece is saying. There's some kind of an angle that will produce 0.8. But if I take the sine of the sine inverse, then I should just get 0.8. Because no matter what that angle is, once I take the sine of it, it's going to give me 0.8. But now here's a different one. Let's say that we have the sine of the sine inverse of 1.3. Well, this one has an issue because of the fact that this is trying to tell me that the sine inverse of 1.3 is something. Well, it doesn't make any sense because, again, sine itself is restricted from -1 to 1, so there's no angle that's ever going to give me a sine value of 1.3. It can't. Has to be in between -1 and 1. So in this case, this is completely undefined. This is just not defined. There is no solution to this. And it's because you cannot get a 1.3 out of doing a sine value. Just not possible. So you do have to kind of look for things like that. Okay, cosine is exactly the same concept as sine. You just got to know your cosine values. So if I wanted to do the inverse cosine of -√2/2. So first of all, you see that the inside of that is a negative value. We know that everything in the first quadrant from 0 to pi halves is going to be positive. So for cosine, it's restricted from 0 to pi, which means this has to be in the second quadrant. So we should know what the angle is in the second quadrant that would give you a value of -√2/2. Okay, that's going to be the pi-fourths equivalency in the second quadrant, which is 3 pi-fourths. So that would be the inverse cosine of √2/2. So again, this is where you really need to know your trig circle values and be able to go kind of forwards and backwards to figure them out. We could do the same thing with composites. We'll take the inverse cosine of the cosine of pi-12, excuse me, not pi halves, and the inverse cosine of the cosine of pi-12, because cosine of pi-12 is first quadrant. The inverse cosine is going to put us right back in that first quadrant. It's just pi-12. Okay, let's say that we wanted to find the cosine of the inverse cosine of -0.4. Well, since the inverse cosine is on the inside, we have to make sure that that -0.4 is on the normal domain that a cosine can produce a value for. And cosine, once again, the values bounce back and forth between -1 and 1, so this one's okay. Now, it is going to actually occur at whatever value that -0.4 would be produced at, so this is just -0.4. And then let's say that maybe we want to find the inverse cosine, this time on the outside again, of the cosine of -2 pi-thirds. So -2 pi-thirds itself is actually going to end up in what would be the equivalency of the third quadrant. It's not really the third quadrant, it'd technically be like the -2nd quadrant. But it's going to ultimately be in the third quadrant. And cosine in the third quadrant is going to produce a negative value. So we need to find the equivalency of cosine of 2 pi-thirds, but we need to figure out what that would be in the second quadrant because that's where it's restricted. So instead of going around the circle, so let me sketch this one real quick. Instead of going around the circle, so -2 pi-thirds would be right about here. Well, we need to go around the circle this direction, and in that case, it's actually going to be at +2 pi-thirds because that's where the negative cosine values, oops, should be positive 2 pi-thirds, are going to exist. And I know I'm running through some of these very quickly, but again, what this really comes down to is you need to be good with the trig values. You've got to be good with knowing these values. Maybe not as fast as me, but you got to have some way of coming up with how to figure this out. All right, so now let's look a little bit at inverse tangent. And that's where we'll end this section once we're finished the tangent. Tangent is generally the same idea as inverse sine because of its restricted domain. So if we wanted to do just a real quick example, like the inverse tangent of 1. So again, you're asking yourself, first of all, it's positive, so it's got to be first quadrant. Tangent of what angle is going to give me 1? This one may not be as easy if you're not as good with the tangent values. This one I just happen to know pretty quickly. It's pi-fourths, and the reason I know that it's pi-fourths is because I think of tangent in terms of sine over cosine. And since sine and cosine are both square root of 2 over 2 at pi-fourths, when you divide the same number by itself, so square root of 2 over 2 over square root of 2 over 2, that's going to give you 1. So I know that that one's a little bit easier to do. Tangent of 0, I just kind of have memorized the 0, so the inverse tangent of 0 would also be 0. Didn't write that one down, but it would be. This one's one that's not going to be quite as easy to figure out. And I will kind of show you the way I think of it. Oops, that should be a negative out front. So this is the way I think of it. Again, I think of everything in terms of sine over cosine. This is actually still to this day the way I think of this. If you've got these all memorized in some other way, whatever works for you, as long as you know them. I think of negative square root of 3 as basically being this. I'm going to put this off to the side. I'm not worrying about the negative right now. I think of that, first of all, as being square root of 3 over 1. And again, because I think of this in terms of sine and cosine, I know that in order to get square root of 3 over 1 by doing a sine over cosine, this had to have come from negative square root of 3 over 2 over 1/2, because those are the x and y coordinates that are going to lead us to this. And this is sine. This one is cosine. So I'm going to ask myself, what angle for sine gives me square root of 3 over 2, or what angle for cosine gives me 1/2? It's the same angle, so it doesn't matter which one you use. I know that cosine is going to give me 1/2 at the 60 degrees, which is at my pi-thirds. So I know this is going to be some kind of pi-thirds, but the fact that it's a negative square root of 3 means that this had to have occurred in what would be the negative first quadrant, again, because of the restricted domain of inverse tangent. So that has to be negative square root of 3. It's got to be in the negative first quadrant or the fourth quadrant equivalency. Okay, it's not really fourth quadrant because you can't go that direction, but negative first quadrant. So again, that's kind of how I figure out the tangents. And tangents are a little bit more difficult depending on how your thought process goes. I don't think that you'll probably ever be asked to do this, but if you needed to find an inverse function based upon something that had trig in it, it's the same process that we did before. You would switch your domain and range, so switch your x's and y's and then solve for y, which would probably give you some kind of an inverse trig function. Just be careful on your domain when you're talking about something where you have an inverse trig function. Again, I don't think I'm going to ask you to do anything like that. Just know that it would be the same process. What I am more interested in, and I'm only doing one example of this because we'll hit this much harder later, is I'm going to introduce you to how you would actually think about solving one of these equations. So let's say that if we are simply asked to solve 3 inverse sine of x equals pi. To solve that, that means we're trying to find the value of x. So the first thing you need to do is isolate the part that has the x in it, which is your inverse sine. So we'll isolate the inverse sine by dividing both sides by 3. And then to actually solve for x, you can take the sine of both sides of this so that we can get the x out of the argument. So the left side, sine of sine inverse of x, is just going to give us x. And on the right side, we just have to evaluate the sine of pi thirds, which in this case is square root of 3 over 2. And because of the fact that we started off with an inverse trig function, you just have to make sure that that is within your domain, and square root of 3 over 2 is within the domain, right? It's got to be something that's going to give us a value between -1 and 1, and this one does. So that's just a real quick introduction. We're going to do some much more involved solving with using trig after we get through some more of the basic lessons first. All right, plenty enough for this video. You should have enough, and we'll come back in the next video. We're going to tackle some basics about the other 3 inverse trig functions.